What is IoT, or Internet of Things? You'll notice here I say definition unknown. If you ask 100 people, you'll get 100 different answers. Is the toaster with an IP address an IoT device? I would say yes. However, is a computer a thing? Computers have IP addresses. They talk on the network. They talk to the internet. Do computers fall into IoT? It's hard to exactly define what an IoT device is. And as I mentioned, you ask 100 people, you're going to get 100 different answers. So we're going to try to clarify some of that throughout these next few slides. The common components of IoT environments or ecosystem are devices, gateways, maybe, and some form of internet or cloud connectivity or service or feature functionality, whatever the case may be. Devices, particularly, let's talk about those real quick. Devices are hardware and they have software on them. They interact with the world. So that toaster with an IP address example I was given, toaster talks to a cloud service. You can go to the cloud service and say make some toast, for example. These devices are defined by metadata. They maintain the state of the device itself, such as an identifier, the model of the hardware, serial number, things like that. These devices send telemetry and or receive commands. We're going to talk about all this stuff throughout these remaining slides, so don't get overwhelmed yet. These devices also connect to some form of network, may or may not be a TCP/IP or UDP/IP network. They might need an intermediate gateway. So I mentioned that the gateway itself may or may not exist. If this device can talk IP, do we need a gateway? This gateway could be a Wi-Fi access point. If the device is Wi-Fi capable, you don't necessarily need a specific purpose-built gateway that does translation from some unique proprietary protocol to IP running across the internet. There are some layers defined that are commonly accepted in IoT deployments. Up at the top of the stack, sitting out on the internet, we have an application layer and a middleware layer. Middleware layer usually receives the data, puts it into a database for display by the application layer. At the gateway level, we have access gateway layer and internet layer, and this takes the data from the constrained network and puts it out towards the internet. And then finally, at the device layer, we have our sensors, RFID, wearables, readers, etc. So these are the actual devices that are part of whatever this IoT thing happens to be. With respect to gateways, I did mention that they may or may not exist. If the device itself can talk IP, do we need a gateway? Could the gateway be an access point? Usually what they will do, in the case of networks that have unique protocols that are not IP routable, that the devices are talking, then the gateway's job is to take that data from that constrained network and get it to the internet, usually using TCP/IP up towards the internet, and then some unique connectivity protocol down towards the device. And we'll talk about some protocols that you might see for this area here in just a moment. And then that final common component, internet cloud, this is the compute infrastructure that's going to receive, process, and store that data and display it to an actual user. Front-end display of telemetry as well as deduced determinations. So whatever AI, ML you have built into your awesome application, you arrive at a conclusion and display that conclusion. Device telemetry. So the devices on the left-hand side of that previous screen are going to collect data. That data is referred to as telemetry, usually collected via sensors. And sensors can be equated to the 5 human senses: touch, sight, hearing, smell, and taste. When it comes to sensors, in the touch realm, so temperature and humidity, these are things that you can feel, as well as air pressure, acceleration, and angle. These are all common sensors that are deployed on IoT devices. For sight, we have cameras, computer vision, detecting that that is a human that is walking into this space. Microphones for hearing. For smell, volatile organic compounds as well as gas sensors all exist. And then finally, taste sensors do exist. I was surprised to hear this as well. This Japanese research paper listed here, this publication, Taste Sensor -3. I would recommend reading that. It's very interesting. It is an actual taste sensor developed in Japan. What defines a device when it comes to the format of the telemetry that is being sent? And what do I mean by that? I have an example here. So we have concise data on the left and verbose data on the right, but they both say the same thing. In this case, on the left, the device is the actual device, meaning the hardware is the device, and it is sending one chunk of telemetry that describes all of the sensors. On the right, the individual sensor itself is the device with respect to the telemetry that's being sent. So here we have type, temperature, value 23.3 degrees Celsius, I'm assuming, humidity 54%, pressure 100.1 kilopascals, probably. On the left, temperature is 23.3, humidity 54, pressure 100.1. Same data on both sides. This is quite a bit more concise. We're looking at 42 bytes versus 119 bytes. However, over here on the right, the sensor itself is a device, and the physical hardware is simply a vehicle to get that sensor data up to the back-end service. So I mentioned that devices can gather information from sensors and send it to the cloud. They can also receive commands and do things, either self-decided or commanded, meaning that the cloud service could say, hey, device, hey, temperature sensor, I want you to read the temperature and publish your data right now, rather than doing it every 15 minutes. Or the cloud could say, temperature sensor, I would like you to, rather than publishing every 30 minutes, I want you to publish every 15 minutes. So these are commands that are being sent to the device to do something. Now, when I say self-decided right here, what I mean is that it is possible to build intelligence into these devices so that they can make a decision on their own. Let me give you an example. Let's say you are monitoring a grain silo, and whenever the fan turned on the grain silo, you should sample the temperature at the top of that grain silo faster. How would you implement this? One, you need an accelerometer on the fan. That's going to start vibrating, and it's going to say, hey, top of the bin guy, it's time to start sampling faster. So that is intelligence built into a solution for monitoring a grain silo, just as a random example. So that's a self-decision. The fan has started, and we need to sample faster, sample the temperature faster. And that's all just built into the code. That's not any sort of AI, ML sort of thing there. It's just the logic of the code says the fan is on, you need to sample faster. When it comes to the compute or the intelligence within these devices, what is in there actually holding the code and doing the work? There are a whole bunch of options out there. It could be as simple as an 8-bit microcontroller and some firmware for very simple type devices, all the way up to a system on chip with embedded Linux or Windows embedded. There's a trade-off between the complexity of the compute and the power required and the cost to implement. Off-the-shelf options for operating systems. So if you're not doing just firmware on a microcontroller, you want to actually run an operating system. Most of the time it's going to be a real-time operating system, and there's a bunch of options out there for you, all off-the-shelf. Put them on your microcontroller and run some form of real-time operating system. We have Riot, ARM Embed, Nucleus, Apache Minute, I'm a pretty big fan of. There's also an Ubuntu Core option to run Ubuntu on, these would be the larger ARM processors.